and narrate with thoughtful patience, like describing careful craftsmanship. Maintain calm authority. This chapter explores how memories move from temporary to permanent storage during sleep. Close your eyes now and let yourself settle deeper into this moment of rest. You've journeyed through the nightly reboot, that descent into slow-wave sleep where your brain waves lengthen into deep, rolling delta rhythms. You've felt the cellular cleanup, the restoration, the quiet power down of the day's demands. But sleep is doing something else too, something extraordinary. As you lie here in the dark, your brain is not merely resting, it is building. Tonight, you're in the presence of the memory architect. Imagine, if you will, that your sleeping brain is a master builder standing before an enormous blueprint. The day has left you with hundreds of experiences. Conversations, images, feelings, facts, the smell of coffee, the face of a friend, the solution to a problem. These moments arrived in a rush, captured quickly, held temporarily. And now, in the deep silence of sleep, the architect begins the patient work of deciding what to keep, where to store it, and how to weave it into the permanent structure of who you are. Let yourself drift with this image. The architect moves through quiet halls of your mind. There are two great spaces in this architecture. The first is small but brilliant, a workshop filled with light, where fresh sketches cover every surface. This is your hippocampus, deep within the temporal lobes of your brain. Think of it as a temporary sketchpad, a holding room for new experiences. When you learn something today, a name, a route, a realization, your hippocampus caught it first, sketching it quickly in bright temporary strokes. But the hippocampus is not built for permanence. It cannot hold everything forever. Its capacity is limited, its storage fragile. If memories stayed only here, they would fade like morning mist. So, the architect has a second space, vast, intricate, and enduring. This is your cortex, the folded outer layer of your brain, stretching across the landscape of your mind like an infinite library. Here, in the cortex, memories are stored permanently, integrated into the rich tapestry of everything you know. This library contains your childhood, your language, your understanding of the world, the face of everyone you love. And tonight, while you sleep, the architect is transferring sketches from the hippocampus to the permanent archives of the cortex. This process has a name. Scientists call it systems consolidation. But you can simply think of it as a great migration, new memories traveling from temporary holding to lasting storage, from sketch to sculpture, from whisper to stone. Sleep, particularly this deep, slow-wave sleep you're entering now, is the essential condition for this work. Research shows clearly that sleep benefits memory consolidation far more than staying awake after learning. When you sleep, your memories stabilize. They become resistant to interference, protected from being overwritten by tomorrow's experiences. The dual-process view of memory teaches us this. Slow-wave sleep, the deep sleep of delta waves, primarily supports what scientists call declarative memories. These are your facts, your events, your explicit knowledge, the what happened and what is true. The birthday party, the capital of France, the conversation that changed your perspective. Right now, in this very moment, as your slow waves roll through your cortex, the architect is selecting which declarative memories to preserve. Breathe slowly. Feel the work happening beneath your awareness. You don't have to do anything. The architect knows exactly what to do. The blueprint is unfolding. The construction has begun. Asked, continue with thoughtful, measured tone, describing the fascinating process of memory replay during sleep. But how does the architect transfer memories from sketch to permanence? How does hippocampal activity become lasting cortical structure? The answer is simple and wondrous. Practice. Your brain practices your memories while you sleep. Deep in the hippocampus, the same neurons that fired when you learned something new are firing again right now. Not because you're thinking about it, but spontaneously, automatically, in the deep silence of sleep. This is hippocampal replay, one of the most beautiful discoveries in neuroscience. In both rodents and humans, neuronal patterns activated during learning are spontaneously replayed during subsequent sleep. If a rat runs a maze during the day, specific neurons fire in sequence: left turn, straight, right turn, go. That night, those same neurons fire again in the same sequence. The rat is running the maze again in its dreams. You are doing this too, right now. If you learned a route today, your place cells are quietly retracing it. If you had a meaningful conversation, the neural ensemble is lighting up again. If you practiced a skill or solved a problem, your hippocampus is replaying the pattern. Here's what makes this remarkable. The replay is compressed. What took minutes or hours during the day is replayed in mere seconds during sleep, like a time-lapse of your experience, sped up, concentrated, distilled. And it happens many times throughout the night. The same memory replayed dozens, even hundreds of times. Each replay is rehearsal. Each rehearsal strengthens the connection. Think of a sculptor returning again and again to the same marble, each pass refining the form. These replays don't happen in isolation. They are coordinated with cortical activity. During slow-wave sleep, your brain generates slow oscillations, powerful delta waves rolling like ocean swells. These act as conductors, coordinating hippocampal replay with cortical receptivity. When the hippocampus replays a memory, the cortex is listening, ready to receive it. Scientists observe this with precision. The hippocampus speaks during the up phase of cortical oscillation, when neurons are most excitable. It's a dialogue between temporary storage and permanent archive. The hippocampus says, "Here, this is important." The cortex says, "I'm listening. Show me again." And between these oscillations, something else appears. Sleep spindles. Sleep spindles are brief bursts of rhythmic activity during stage 2 sleep. They last just a second or two. But they are powerful allies of learning. Research shows spindle quantity and quality correlate with memory improvements. More spindles mean better retention. They facilitate synaptic changes that make memories stick. Think of spindles as the architect's precision tools for etching memories into cortical stone. Now, let's connect this to artificial intelligence. In machine learning, neural networks learn by training. Algorithms adjust internal connections to recognize patterns better. One pass-through training data is called an epoch. Networks train for hundreds of epochs, refining weights, strengthening useful connections, weakening others. Your brain does exactly this while you sleep. Hippocampal replay, repeated overnight, resembles training epochs. Each replay strengthens synaptic connections. Neurons that fire together wire together. Biological networks adjust synaptic strengths through replay, just as artificial networks adjust weights through training. This reflects a deep principle. Repetition with variation builds robust representations. Your sleep is training you. The architect runs epoch after epoch, refining neural networks that encode your day. Breathe into this knowledge. Feel the quiet diligence of your mind. You are being strengthened as you rest. The tone should become slightly more contemplative here. We're exploring the deeper work of sleep. But the architect's work is not only about strengthening, it is also about letting go. Not everything from today deserves permanence. Not every neural connection formed during the day is worth keeping. Some were fleeting, irrelevant, mere noise against the signal. And if the architect preserved everything indiscriminately, your mind would become cluttered, overwhelmed, unable to see the essential through the trivial. So sleep does something counterintuitive. It weakens connections too. This process is called synaptic homeostasis, and it is a kind of elegant pruning. Think of it this way. During waking hours, learning is greedy. Your brain forms new synaptic connections promiscuously, capturing every experience, every stimulus. By day's end, your neural networks are dense with connections, many weak, redundant, or context-specific. If this continued indefinitely, you would face a problem. Strong signals would be lost in noise. Energy demands would skyrocket. The system would saturate. Sleep prevents this. During deep sleep, the overall strength of synaptic connections is downscaled, reduced proportionally across the board. Weak connections, activated only once or twice, may disappear entirely. Strong connections, activated repeatedly or in meaningful contexts, survive the pruning and remain prominent. The result is a crisper, cleaner neural landscape. The signal emerges from the noise. Important memories stand out in sharp relief. This is why high-quality slow-wave sleep, with strong delta power, is associated with better overnight retention. The pruning is not random. It is intelligent. The architect knows what to keep. And here's something even more subtle. The memories that survive are not just strengthened. They are integrated. Your brain does not store memories in isolation, like files in separate folders. Instead, it weaves them into existing structures of knowledge, what scientists call schemas. A schema is a framework, a mental model, a constellation of related concepts. When you learn a new fact, it doesn't just sit alone. It connects to what you already know. It finds its place in the broader pattern. This integration happens particularly during REM sleep, the dream stage that follows your deep NREM cycles. While slow-wave sleep stabilizes new memories, REM sleep modifies them, reshaping them to fit into existing schemas. The sequential view of memory consolidation emphasizes this. NREM and REM together form a sequence where memories are first stabilized, then integrated. And sometimes, this integration changes the memory itself. You may have noticed this. A memory, recalled weeks later, is not identical to the experience itself. It has been smoothed, simplified, connected to other memories. Details may shift. The emotional tone may mellow or intensify. This is not a flaw. It is a feature. Your brain is not a video recorder. It is a meaning maker. By integrating new memories into existing knowledge, the architect ensures that your understanding of the world remains coherent, flexible, and useful. You don't just accumulate facts, you understand. Let yourself rest in this idea. Your memories are not static files. They are living, evolving structures, reshaped by each night's sleep to serve you better. The architect is not just preserving the past. The architect is preparing you for the future. And this pruning, this integration, solves a problem that has long puzzled artificial intelligence researchers: catastrophic forgetting. In early neural networks, when an algorithm learned something new, it often overwrote what it had learned before. Train a network to recognize cats, then train it to recognize dogs, and it might forget the cats entirely. This resembles what might happen without adequate sleep. Without stabilization and pruning, new experiences might overwrite older memories. But you don't suffer catastrophic forgetting. You can learn new things and retain old knowledge. And sleep is why. The architect works every night to ensure continuity in cumulative growth. Continue with the thoughtful tone, now connecting biological sleep to AI innovation. And now, in these next moments, let's step back and see the larger picture. The beautiful convergence between your sleeping brain and the algorithms inspired by it. For decades, researchers in artificial intelligence have been trying to build machines that learn the way you do. Not just learning once, but learning continually. Acquiring new knowledge without forgetting the old, integrating new experiences into existing frameworks, balancing stability with plasticity. And increasingly, they are turning to sleep for inspiration. Here's what they discovered. Introducing sleep-like replay phases into artificial neural networks can dramatically reduce catastrophic forgetting and restore performance on older tasks. The approach works like this. An artificial network is trained on a task while awake, learning actively, updating its connections in response to new data. Then it enters an offline phase, an artificial sleep, where it receives no new input. During this sleep phase, the network spontaneously generates activity, replaying patterns from memory without external guidance. Just like your hippocampus replays memories while you sleep. During these artificial sleep phases, something remarkable happens. Representations of older tasks become sparser, more refined, less cluttered. The replay prunes connections that overfit the most recent task, protecting previous knowledge from being overwritten. The network emerges from its artificial sleep more balanced, capable of performing both new and old tasks. One research team showed that this simple addition, intermittent offline processing analogous to sleep, made machine learning more continual and robust. The network didn't forget. It accumulated knowledge over time, just as you do. Another approach draws inspiration from complementary learning system theory. The idea that your brain has two systems for learning, a fast-learning hippocampus and a slow-learning cortex. The hippocampus captures new experiences rapidly. The cortex integrates them gradually, over many nights, into stable long-term representations. AI researchers have built networks with separate fast and slow modules, mimicking this architecture. The fast module learns quickly, like your hippocampus. The slow module learns gradually, like your cortex. During artificial sleep, the fast module replays its recent experiences to the slow module, allowing gradual consolidation without catastrophic interference. The alternation of NREM-like stabilization and a REM-like integration has even been modeled in AI. Some algorithms alternate between phases that strengthen recent learning and phases that integrate and reorganize knowledge. This mirrors how your sleep cycles balance plasticity and stability, ensuring that you can both adapt to new information and retain the structure of what you already know. The convergence is profound. It shows that the biological solution your brain discovered millions of years ago, alternating online learning with structured offline replay, is a fundamental computational strategy. It works in brains. It works in machines. It may be a universal principle for building durable, flexible intelligence. You are carrying this ancient wisdom in your very neurons. Every night, while you sleep, you are demonstrating a solution to one of the hardest problems in learning: how to grow continually without losing yourself. The architect in your mind is a master of this balance, strengthening the new without erasing the old, integrating today's lesson into the library of your life, pruning the noise to reveal the signal, replaying, refining, consolidating. And now, let yourself appreciate what is happening inside you. You are not merely resting, you are being rebuilt, night after night, into a more integrated version of yourself. The work is patient, the work is precise. The final section should slow down even more, becoming contemplative and peaceful. So sleep now, with the confidence that this process is unfolding exactly as it should. The hippocampus is replaying, the cortex is listening, the slow oscillations are rolling through like gentle waves. The spindles are etching, refining, securing. The synapses are strengthening what matters and releasing what doesn't. The architect is at work. And when you wake tomorrow, you'll find that you remember more than you expected. You will find connections you didn't see before. You will find that today's confusion has become tomorrow's clarity. Because tonight, while you rest, the memory architect is building you. Let go now. Sink deeper. Trust the blueprint unfolding in the dark. Your memories are being carefully, beautifully preserved. Your knowledge is being integrated into wisdom. Your mind is being prepared for all that tomorrow will bring. Sleep well. The architect has everything in hand.